Okay, one thing to mention, please make sure you don't put any semicolon here. Okay, that's a common mistake. Don't feel shy. If you really put it, but just make sure you don't put it in the lab test. Nobody's gonna fix that for you. Even myself, I couldn't spot it actually. Okay, please don't put any semicolon here. Okay. Okay. So let's just extend the program a little bit. So now, since we got an array of integers, why don't we do some interesting stuff? For example, can we figure out if all the numbers are positive, which we did in the lecture? Let's do that first. And also we can figure out what's the maximum value, which I will talk about on Thursday. But we can do it right now. Okay? Let's say we do these two. So we'll figure out if all the numbers are positive. I'm going to show you all the four versions. All positive, and also we have the maximum. Okay, we're going to do these two. Okay, let's do it together. So once we get the numbers we read from the user, so now you have entered this many numbers, and let's say if they are all positive, right? Let's try to figure that out. Okay, so remember we got four versions of figuring out if they are all positive. Let's try all the four versions right now. Okay, remember only one version didn't work, but we'll see why it didn't work. Okay, so let's try this. Version 1. Okay, I'll do exactly the version sequence in the slides. So you can say for integer I is assigned to 0, I less than numbers dot length I plus plus. Because now we know that so far the number has been somehow initialized to be some size according to the user's size, right? According to how many they want to handle. Now I want to show you something. Okay, I'll show you just in a moment. Okay. So now let's say this version 1, and then how do we figure out if all the numbers are positive? Let's do the easiest version. We're gonna need a Boolean variable so far positive is assigned to be true, and we explain why it has to be true in the lecture today. So now we can say so far positive is assigned to so far positive conjunction with the current number. We are talking about numbers at position I larger than 0. Okay, I'll let you type. That's what we need. After that, we should get a correct result. But I'll show you something that's very interesting. Okay, so now let's say system.out.println. We can say all numbers are positive. And here you can say either so far positive, either true or false. Let's just make it simple. Okay, let's try. Okay, just that. You can just print out this Boolean variable here, which will be accumulated to the correct result, right? Either true or false. Let's try this. If you try, let's say this, how many numbers? Let's make it 3 numbers. Enter a number, what about 23? Would you like to continue? Yes. -1? Yes, I want to continue. What about 24? I'm done. So now I've got 23, -1, and 24. Result should be false. No, I don't want to continue. Okay, all numbers are positive, false. Okay? Right. Now, there is an issue over here I want to show you. It's quite important, actually. So now, I want to show you one more. Well, let's try a different problem. How about this? All positive, and then also, if all the numbers are odd numbers, all odd numbers. Okay? If there's any even number you see in the array, it's going to be false. If all the numbers are odd numbers, it's going to be true. Okay? That's what we're going to do. Okay? But before I do that, why don't I show you the other three versions for this, just for completeness, and then go for this one. There's something I'd like to show you very important. Go there in a moment. Okay. Okay, version 1. Let's see version 2. Version 2. And I can simply, how about I just rename this variable here to be so far positive 1. Okay, just to be clear. Can we just click on this variable here, right click, and then you can go to refactor over here, and you can go to rename. Right click on the variable, and then go to refactor, and then rename. So now you can rename that to be so far positive 1. That means that's the variable for version 1. Enter, and done. It has done the renaming for all the occurrences of this local variable here for you, which is pretty good. Okay, let's try version 2. For that, let me be a little bit lazy here. Can we just copy version 1? Just copy that. Okay, copy the whole version 1. And paste for version 2. It wouldn't compile, of course, because we are redeclaring so far positive 1. Just change that to 2. So far positive 2. And now let's make sure we change all the relevant places. So now let's go to so far positive 1. That should be 2. Okay, and this should be 2 as well. And this should be 2 as well. That's kind of version 1 duplicates, but let's change that to version 2. For version 2, I'm simply going to delete this part of conjunction. Just that. That's what we said in the class today, right? About version 2. And we said that this one would not work. Okay? I'm going to give you an input array that is not going to work, right? So what we said in the class earlier this morning was, if the negative number you have is not at the end of the array, it is not going to work. Okay? Let's try. So version 2 sometimes works, but sometimes does not work. Okay? Let's try. So can I just comment out version 1? Okay? Let's comment this out. You can select the whole block and then Control /. That's how you comment out the block. Let's see for version 2, how do we do with that? Okay, let's go to version 2 and then let's say 3 numbers. Let's try an array, a sequence of numbers that will work for version 2. And I'll show you a version that wouldn't work. Okay, so now enter a number. What about, I'd say 23. I want to continue. 46. I want to continue. -1. You can see the negative number appears at the last of the array. I don't want to continue. It's false. It is not the case that all the numbers are positive. That's okay. So this one works. I'm going to give you another sequence, which is not going to work for version 2. Okay, let's try. How about this? If I have 3 numbers over here, let's say I got 23. I want to continue. Now the negative number is in the middle, -1. I want to continue. 46. Okay, you can see a negative number is not in the middle. I don't want to continue. That gives me true, right? That's why I said for version 2, it works only under certain circumstances, but not others. So I'll document that for you. You can look at the source code later. Okay, you can say it works. Works if you got 23, 46, -1, which means negative number appears at last. And it fails if you got 23, -1, and 46, for example. So which means the negative number appears in the middle only. It doesn't appear at the last. Okay, so that's something you should really convince yourself why. Version 1 and version 2 looks very similar. But version 2, just because we take out the accumulative conjunction there, it wouldn't work. It stopped working. Sometimes it works, sometimes it doesn't work. Let's try version 3 and version 4, and then we'll go to the next design. version 3 and version 4. So now, let me just, okay, let's go for version 3. Okay, for version 3, can we just cheat a little bit? What about go to version 1 and copy that? Okay, copy that and paste. Okay, I can uncomment that. By the way, comment, uncomment would be control / the same. Okay, so now let's call that so far positive number 3. Okay, let's just rename that to be 3. 3 here, 3 here, and 3 here. And then 3 here. Okay, now the way we're going to do this is by a more efficiently. We want to say as soon as we see a negative number, we're going to exit, right? So that means we're going to put conjunction here, so far positive 3. Okay, we're just extending the result over here. But how do we see that? Okay, the way we see that is by seeing what comparison we have done. So let's do something here. Okay, we can say system.out.println comparison. You can say numbers at position I larger than 0, which is that result. Okay, give me a moment. I think I just make sure to put the brackets around. Okay, that'll do. I'll let you type. So basically, we want to see how many comparisons we actually do for this early exit version. You'll realize that we only do as many comparisons as necessary. As soon as we get to the negative number, we'll exit. We'll see that. Okay. Okay, let's try that. Okay. Let's try this version 3. Can we just comment out version 2? For version 3 over here, let's try this. How many numbers? Let's say 5. 5 numbers. 23, let's say 12. I want to continue. 24, I want to continue. Let's say the third number is negative, -1. And then, would you like to continue? Yes. Let's say I got 36, which is not negative. I want to continue. 48. So far, what have we got? We got 12, 24, -1, 36, 48. That's what we got. So somehow, for the early exit version, we would expect the loop only compare the numbers up to here. As soon as we find out -1 is encountered, which is negative, we wouldn't bother to continue. Right? That would be the early exit. Okay? Let's see that. Would you like to continue? No. You see, only that. You can see that's quite nicely tell you that as soon as you find out it's actually false, you will stop right away. You will exit. Let's try this in the version number 1 to see what's going to happen. Let's compare. Okay, if you try this one in version number 1, let me say try. I will put it down for you. Try an array 12, 24 -1. 36, and then 48. Okay, so can we just copy this line here for the printout? Just this line here. Okay, system.out.println comparison. Can we just go back to version 1? Can we just uncomment version 1? And I want to print out this as well. Okay, all the same line. I want to show you. So can we just have another print statement before version 1? System.out.println. Version 1 without early exit. Okay, copy this line here. Go to version 3. So here we can say with early exit. Okay, we're gonna see. So in the versions where there's no early exit, we're gonna do 1, 2, 3, 4, 5 comparisons. In the case of early exit, we're gonna do 3 comparisons only. Right? That's what I want to demonstrate. Let's try. Okay, let's run the program here. And then how many numbers would you like to do? 1, 2, 3, 4, 5. 5. So let's say 12. I want to continue. 24. I want to continue. Minus 1. I want to continue. 36. I want to continue. And then 48. Okay? Once I hit this, we're going to run version 1 followed by version 3. Okay? Oh, no. Let me continue. Let's see this. Version 1. How many comparisons do? We do 1, 2, 3, 4, 5. 5 comparisons. And you will get true, true, false, true, true. Even though you already encountered false in the 3rd iteration, but you wouldn't give up. You just continue. But in the version, I should say version 3. Sorry about that. I'll fix that. Okay. And in version 3, what you will get is as soon as you hit false, you will stop. That's the early exit version. Okay. Questions? Okay, that'll be version 3 with early exit. Okay. Fix that. So finally, let me show you version 4, how the code should look like. Then we can pause a little bit, and then I will show you one more example. Can we just copy version 4? Okay, just copy version 4. Okay, version 4, if the indentation goes out of order, you can Control A and Control I to fix it back to the place. Okay? So let's call that version 4. Okay? And then version 4, I don't need the print line anymore. Okay, that's the illustration is done. So far positive 4. Okay, so now so far positive 4 in the state condition there. Okay, and then we don't have condition here, conjunction anymore, just that. And that should be so far positive 4. Okay, and you can delete this printout over here. Okay, we don't need that either. Okay, version 4. So now this version 4 here, also it is going to do an early exit because we have as part of the state condition so far positive, right? But now this version also works because as soon as the current comparison becomes false, it's going to make the state condition there false because it's conjunction, which will make the loop to exit, right? So this version also works. I'll let you try. So now I've shown you all the 4 versions I talked about in details in the lecture today. Hopefully that makes sense. Okay? It's really important not only to know what to work, but what not to work. That's also important. Okay, I'll pause here for a few minutes. If you got questions, please ask around the TA. And then I'll do another example to extend this one, and then I'll give you a new exercise.